Let's just jump right in, shall we? Welcome to this explainer of the newly released 2026 Stanford AI Index report. This is hands down one of the most comprehensive, independent looks at the state of artificial intelligence in the world today. And what we're looking at here is a technology that hasn't just arrived, it's practically taken over. It's hitting mass adoption at a pace that frankly makes the rollout of the internet look like it was moving in slow motion. But as we're going to see, the main theme of this year's data isn't just about how fast AI is moving. It's really about what it's leaving behind. We are tracking a widening gap. I mean, just look at this number, 53%. In barely 3 short years, generative AI has hit a 53% population-level adoption rate. More than half of us are already interacting with this tech on a regular basis. When you stop and think about how long it took for smartphones or, social media to reach that kind of saturation, this 3-year sprint, it is practically unprecedented in human history. And that blinding speed brings us straight to the core thesis of this whole explainer. The report's co-chairs, Yolanda Gill and Raymond Perrott, they really hit the nail on the head here. They wrote, "The data reveals a field that is scaling faster than the systems around it can adapt." And honestly, that right there is the central tension we're going to unpack today. It's this massive, ever-expanding gap between AI's wild capabilities and our own societal preparedness. Our governance, our schools, our safety protocols. We're playing catch-up. So, let's start with Section 1, the acceleration of AI, a field moving fast. To really wrap our heads around this gap we're talking about, we first have to grasp the sheer speed at which AI research and technical performance are scaling up. Take the SWE Bench Verified Coding Benchmark, for example. This is a test of an AI's ability to solve complex, real-world software engineering problems. In 2024, the best models out there were hitting around 60% of the human baseline. Pretty good, right? Well, fast forward just one single year to 2025, and that performance leaped to nearly 100%. In basically the blink of an eye, AI went from being this helpful but kind of flawed coding assistant to matching the human baseline on this evaluation. It's a completely breathtaking jump for just 1 year. And the thing is, this rapid advancement, it is definitely not localized to just one company or one single country. Back in February 2025, China's DeepSeek R1 model briefly matched the top model out of the US. And notice how incredibly razor-thin that margin is right now. As of March 2026, Anthropic's top model holds a lead of just 2.7%. So what we're seeing is the world's top 2 AI superpowers literally trading the lead back and forth month by month. But here's the catch. Software performance is really only half the story, right? Because these models, they have to live somewhere physical. And that creates a wildly fascinating contrast in global infrastructure. On one hand, you have this massive physical footprint. The US currently hosts over 5,400 AI data centers. That is more than 10 times the amount of any other country. But check this out. Almost all of those data centers completely rely on leading AI chips manufactured by exactly one company, TSMC in Taiwan. So we've built this massive, sprawling infrastructure, but it's bottlenecked by an incredibly fragile single-point supply chain. Moving on to Section 2, the jagged frontier, brilliance and blind spots. Researchers actually use this term, the jagged frontier, and it perfectly describes how these systems can be simultaneously superhuman and yet surprisingly inept at the most basic things. For instance, we've seen a world-class achievement where the Gemini DeepThink model actually won a gold medal at the International Mathematical Olympiad. It's out there solving incredibly complex PhD-level math problems. But on the flip side, it's honestly kind of hilarious. The absolute best frontier models can only read a traditional analog clock correctly about half the time. Think about that. It can breeze through math that would totally stump a college professor, but a regular old clock on a wall practically breaks its brain. And we absolutely see this jagged frontier apply to the physical world too. If you look at software-based simulations, robotic AI is crushing it, hitting nearly 90% success rates on certain benchmarks. But take that exact same AI, put it inside a physical robot, and ask it to do a real-world household chore, you get an 88% failure rate. So that gap between a highly controlled laboratory setting and the chaotic, unpredictable messiness of your living room, it's still a massive hurdle for AI to cross. Which brings us to Section 3, Real World, Real Costs, exploring the economics and environment. As AI scales up this rapidly across all these industries, it's leaving a very real, very tangible footprint on our economy and our labor markets. First off, the sheer amount of money involved is astronomical. U.S. private AI investment alone hit over $285 billion. And hey, it's working. We are seeing software developer productivity shoot up by 14 to 26%. But there's a huge catch here. At the exact same time we're celebrating these massive efficiency gains, employment for entry-level U.S. developers, specifically those ages 22 to 25, has actually dropped by nearly 20% from last year. Basically, AI is doing the junior-level work now, and the labor market is reacting instantly. It's essentially hollowing out that traditional entry-level stepping stone. Speaking of the labor market, there is this massive, frankly surprising contradiction buried in the report. So while the U.S. absolutely dominates the globe when it comes to private AI investment, its ability to actually attract global AI talent is falling off a cliff. Get this, the influx of AI researchers moving to the United States dropped by an astonishing 80% in the last year alone. The money might all be in the U.S. right now, but the global talent pool is increasingly deciding to just stay home or go somewhere else entirely. Now, we also really need to ground the abstract concept of AI software in its physical, environmental reality. Because, the cloud isn't actually floating up in the sky, it's housed in massive, energy-hungry data centers. Just training a single frontier model like Rock 4 generated an estimated 72,000 tons of carbon dioxide equivalent. And it's not just electricity. It takes a staggering amount of water to cool these servers down. The annual water usage just for running inferences on GPT-4o is estimated to exceed the drinking water needs of 1.2 million people. The environmental costs are scaling right alongside the capabilities, and it's something we absolutely have to reckon with. Let's look at Section 4, Society Catching Up, Safety and Schools. So, how exactly are our vital human institutions adapting to this sudden AI integration? Well, the short answer is they're struggling. Take the healthcare sector, which shows a really stark disconnect. On the positive side, AI ambient scribes, these are tools that listen to a doctor's visit and automatically type up the clinical notes, are saving physicians up to 83% of their documentation time. That is huge for reducing doctor burnout. But beneath that shiny surface, the underlying science is seriously lagging. Only 5% of clinical AI studies actually used real-world patient data. The rest just relied on standardized exam-style questions. And meanwhile, documented global AI safety incidents rose significantly from 233 to 362. We are literally deploying these tools faster than we're validating their safety. And if you really want to see this systemic lag in action, just look at our education system. The Stanford Index points out that over 80% of students are actively using AI for school-related tasks right now. But what percentage of teachers say their school actually has a clear AI policy in place? Just 6%. Think about that gap. The students have fully embraced and adopted the technology, while 94% of educators are essentially left operating completely in the dark in a total policy vacuum. Finally, Section 5, the global trust divide, a crisis of confidence. As AI continues to infiltrate all these critical systems, there is a massive psychological disconnect unfolding across the world. When you ask people about AI's impact on jobs, 73% of AI experts are highly optimistic. They see the incredible productivity gains on the horizon. But the general public? Only 23% share that optimism. That is a massive 50-point divide between the people actually building the technology and the people whose everyday lives are being changed by it. The builders are thrilled, but the public is, understandably, incredibly nervous. And that widespread nervousness translates directly into a remarkably fragmented global policy landscape. In the United States, public trust in their own government to effectively regulate AI is sitting at just 31%. Actually, on a global scale, the European Union is trusted more than either the US or China to handle AI regulation properly. And while all this is happening, developing nations aren't just waiting around to see what the big players do. They are rapidly expanding their own national AI sovereignty strategies to make sure they aren't left entirely dependent on just a handful of foreign tech giants. Which brings us right back to the exact point where we started today. AI model performance is accelerating at a breakneck pace. It is completely reshaping our labor markets, consuming massive amounts of natural resources, and pushing this jagged frontier into our schools and our hospitals, all while public trust remains deeply divided. So the ultimate question the Stanford Index leaves us with is a profound one. As AI continues to scale faster than the very systems we've built to manage it, Are we truly prepared for what comes next? Thank you so much for joining me for this explainer, and I highly encourage you to go read the full report to explore these vital questions for yourself.